Hi guys, so today we're talking about lateral area and surface area again, but of different types of figures. We're talking about pyramids and cones this time. Also related, like how prisms and cylinders were related, but I believe this is coming from section 12.3 in the textbook if you guys still look at that. So I think, like, we talked about what lateral area actually is. The lateral faces, so like if this is your pyramid, right? The lateral faces, again, if you don't remember, are the faces, the faces of the figure, not including the base. So all the way around would be your lateral faces, and the lateral faces, as you guys can tell from the picture, intersect at a common point called the vertex, which is up here. A regular pyramid has a base that is a regular polygon, and the altitude has an endpoint at the center of the base. Pretty self-explanatory. All the lateral edges are congruent, all the lateral faces are congruent isosceles triangles. I think really the only key thing I want to stress here is this last sentence. The height of each lateral face is called the slant height of the pyramid. All right? Pyramids, their lateral faces are triangles, which is different from how the lateral faces of prisms were rectangles. So the height of any one of those faces is not, it's different from the height of the actual prism itself. The height of the pyramid. The height of the pyramid has to still be perpendicular to the base. Same thing is true with prisms. But when we talk about the slant height, it's the height of one of the lateral faces. So, I mean, you can kind of visualize it in your head. If the faces of the pyramid are slanted, the height of each of those faces is going to be slanted as well. That's probably where slant height, the name itself, comes from. Maybe. Who knows? And that, I think, is all I have to say about that. It is written with a cursive letter L, so you can probably guess that it is going to show up in the formula for lateral area and for surface area. Is that everything I wanted to say about this? I think so. If I think of anything else, I'll come back to this. But here's a formula for lateral area of a regular pyramid. All right? Lateral area is equal to half of times the perimeter times L, which is your slant height. All right? It does specify regular pyramid for a reason. Lateral area, again, in general, is the sum of all of the lateral faces of a solid. So I think there might have been a couple questions back in the prism assignment that weren't, I don't want to say they weren't regular prisms, but like weird things were happening. And when it would ask you for the lateral area, you would end up having to go by the straight up definition and take the areas of all four of the faces and then add them up. So that's what you would probably have to do if it didn't specify that that your solid was a regular pyramid. I think most of the questions in this presentation are regular pyramids. It will, or it should probably specify, I hope. But yeah, that's another formula that you guys are going to have to know for this. So I'm going to keep this off to the side on my end just for my reference. And luckily, example 1 is pretty easy because we have that this pyramid is a square pyramid. So the base is a regular polygon, which means we can just go in and use this lateral area formula. So L is 1/2 times the perimeter times the slant height. Since it's a square, all four sides are congruent. So the perimeter is going to be 2.5 times 4, which is 10. So this is half of 10. And then this right here, because it goes from the vertex to the edge of the base. This is your slant height, so times 5. So half of 10 is 5, times 5 is 25. And we're still talking about area, so I am going to look for units, and it is units squared, centimeters squared. Okay. Oh, that's it. All right, we'll probably come back to lateral area a little bit later. But surface area for a pyramid is very similar to kind of how we were talking about surface area with a prism. Prisms have two bases. So the surface area of the whole thing is just the lateral area plus the area of those two bases. That's where the 2b was coming from in the formula. So surface area of a pyramid is very, very similar. The only difference is, well, the lateral area formula is different, but it's also the fact that a pyramid only has one base. So when you add on the area of the base, you're just adding one single B to your lateral area. All right, that's the only difference. So again, we're given the fact that it's a square pyramid. All right, that helps us a little bit. The problem runs into the fact that we do not have the slant height. All right, so I'm going to actually write down the surface area formula real quick. It's 1/2 times the perimeter times the slant height plus the area of the base. All right, so this is 1/2. Again, it's a square pyramid, so 8 times 4 is 32. But this right here in blue would be our slant height, which we don't have. All right. What helps though is the rest of the information of the figure. The 6 is the height of the actual pyramid itself, and this 4 connects the base of the height, I guess. It would technically speaking be the apothem of the square. You don't need it to find the area of the square because you can easily find the area of the square. But what it's useful for is the fact that this 6, this height 6, this apothem 4, and the slant height L create a right triangle, and that's signified right here. So you can do real quick Pythagorean theorem with it to find the actual length of the slant height. So this is going to be 6 squared plus 4 squared equals L squared, because these two are the legs. This is 36 plus 16, which is 52. So this is, I think that's 4 and 13, right? 52 is divisible by 4. Yeah, so root 52 simplifies into 2 root 13. So that is our slant height. And then plus the area of the base. So area of a square, you could just do side squared. So 8 squared is 64. So half of 32 is 16 times 2 is 32. So again, if this was asking you for an exact answer, I would ask you to leave this as 32 root 13 plus 64. You wouldn't be able to combine those again because one of them doesn't have a radical on it. That's what I'd ask you to leave it as if it was asking you for exact answers. But since it does say round to the nearest tenth, I'm just going to plug this into my calculator real quick. Make sure you hit that right arrow so you get out of the radical if you're using a TI-34. So the surface area is approximately 179.4 meters squared. Okay? All right. All right, so let's see here. So slightly more complicated because now we've got a hexagonal pyramid this time. But it still probably won't be so bad. Surface area is still the exact same 1/2 perimeter times the slant height plus the area of the base. So we know it's a regular pyramid, so that's half the battle. It's a hexagon, so all the sides are the same. So 10.4 times 6. The perimeter is 62.4. 15 is your slant height. And the problems come when we have to find the base. Because this is one of those 1/2 apothem times perimeter kind of things that you would have to use for regular polygons, you know? So I'm going to see how much I can fit in right down here. So if this is our hexagon, pretend that's a regular hexagon. Our side is 10.4. And we're going to go all the way back to when we did this in the last chapter and we found the central angle. So the central angle would be 360 divided by however many sides there are. 360 divided by 6. This is 60. Which means the other two angles are also 60. drop your height. It creates, well, that is a horrible looking triangle, but we're just going to go with it. It creates a 30, 60, 90 triangle where the short leg opposite the 30 is half of 10.4. So that would be 5.2. And it would be those measurements that you would be using for the rest of the parts of the triangle. Hypotenuse is double 5.2, so it's also going to be 10.4. And then your long leg is your short leg times root 3. So this is 5.2 root 3. And that's the apothem in the figure. All right? So I'm actually going to write that all out. The area of the base is 1/2 times 5.2 root 3 times the perimeter, which is the exact same perimeter we used over here. So that's also going to be 62.4. All right? So I'm going to have to put this in my calculator. So 62.4 divided by 2 is that times 15 is actually a pretty nice number, 468. I'm going to leave the radical 3 in there for now just to try to show you what the exact answer would be. So 5.2 divided by 2 times 62.4 is kind of a, not that bad of a decimal. So this is plus 162.24 root 3. I don't think I would give you something ridiculous like this on a check or in terms of like leaving this as the exact answer, you know, because there are decimals and radicals and it's kind of a lot. So we're just going to go right in and round to the nearest tenth. So we're going to multiply that by root 3 and then add 468 onto it. So this is actually about 749. Approximately 749 centimeters squared. Something like that. And this is really similar because it's another regular, it's another regular pyramid. You have that information because all the sides of the base are congruent with the tick marks. So it would be the exact same surface area formula. It would be the exact same half of the apothem times the perimeter business. It's just a pentagon this time. Actually, you know what? I think I'm going to do it because it's a pentagon, and so the numbers are probably going to be super, super weird. So surface area is 1/2 PL plus the area of the base. So the side length is 12. So 1/2 times 12 times 5, which is 60. And then this is your slant height, so it's 14.6. So, excuse me. When we draw in a pentagon this time, this is 12. And the central angle is 360 divided by 5, which is 72. So that means when we split that triangle in half to create a right triangle, down here is 6, but up here, the angle is 36. All right? So to find the apothem, which is just this, we would have to use trig. It is going to be tangent, opposite and adjacent. So down here a little bit. So the tangent of the angle 36 is opposite over adjacent. So if this is the apothem, we'll call it A. 6 over A. So A is equal to 6 divided by the tangent of 36, which is approximately 8.26. All right. I think I'm going to leave this in my calculator for as long as I can, but for like, what's the word I'm looking for? So I don't write a huge long decimal on my paper. I am going to write 8.26 on my paper. So yeah. So this is, again, we'll go with the area formula. 1/2 of approximately 8.26 times the perimeter, which is again 60. So we'll work with this first because the 8.26 is still in my calculator. Divide this by 2 times 60 is approximately that. And we're just going to go right in and round it. Now we'll keep rounding it to the nearest tenth just for consistency's sake. So this is plus, I'm going to put this in parentheses, 0.5 times 60 times 14.6 the whole thing, the whole surface area, oh geez, okay. Well, the whole surface area is approximately 685.7 miles squared. And I completely forgot that it also said lateral area. I didn't realize that. So the lateral area, thank God, is a whole lot easier. It's just this first part of the surface area formula. 1/2 times the perimeter times the slant height. So it's just the 1/2 times 60 times 14.6 part, which should get us a nicer number. So half of 60 is 30 times 14.6. It is a lot nicer. It's 438 miles squared. So, same kind of thing like with perimeters and cones, right? We talk about the axis, right? It's same kind of thing with cylinders and stuff. Cylinders have an axis. So the axis in a cone connects the vertex to the center of the base. If the axis forms a right angle, or if the axis is also a height, then it's a right cone. If the axis is not the altitude, then it's an oblique cone. There's your difference in the pictures. And it's still going back to the whole idea that whatever you're using for your height still has to be perpendicular to the base. And again, cones are really just circular pyramids, all right? So if you go back to the lateral area in a pyramid, you're cutting the perimeter in half, right? So the perimeter of a circle is 2 pi r. So cutting 2 pi r in half divides it by 2, which leaves you with just pi r. So that's where that part of the formula comes from, pi r, and then you're still multiplying it by the slant height. And then the surface area is, again, you're just taking that lateral area and then adding on the area of that one single base, which since it's a cone, it's always going to be a circle. So plus pi r squared. So this 3.2 is talking about your slant height. Oh, this is the only problem, I guess. Okay, cool. We're almost done. All right. So surface area is pi RL plus pi r squared. So pi, the radius is 1.4. So 1.4 times the slant height, which is 3.2, plus pi times 1.4 squared. So 1.4 times 3.2 is 4.48. So this is 4.48 pi plus 1.96 pi. They do both have pi, so you can combine those. So the exact answer, since this is a not too terrible decimal, would be 6.44 pi centimeters squared. Leave the pi in for the exact answer, but then rounding that off to the nearest tenth gets you approximately 20.2 centimeters squared for your surface area. All right, so I did say that was the last problem, I'm pretty sure. Yeah, I'm pretty sure that's the last problem. So there's your kind of lateral area and surface area conversation about cones at the same time. You still have to read carefully in terms of whether the question is asking you for the lateral area or the surface area. But there's everything that we've talked about up to this point. We've got prisms, cylinders, pyramids, and cones. We are going to talk about spheres next, which comes from a different section. So we're not completely done with surface area yet, but that's it for today. I know you guys know where to find me if you need help. And yeah, that's it. Talk to you guys soon.